Welcome to Aeronet's Visual Simulation Training Program for the Airbus A320. The A320 Navigation System provides the crew and various aircraft components with data throughout the flight. The main groups within the navigation system are the Air Data and Inertial Reference System, or ADIRS, which utilizes 3 Air Data and Inertial Reference Units, or ADIRUs, which supply air data information such as airspeed, altitude, angle of attack, and temperature, and inertial reference information such as attitude, track, heading, accelerations, and aircraft position. The standby instruments are used as a backup if data from the ADIRS is lost. Dependent systems provide navigation data using ground installations. These components are 2 VORs, 2 DMEs, 2 ADFs, and 2 ATC transponders. The landing aids are comprised of 2 ILSs and 1 marker system. Independent systems, such as radio altitude, the weather radar, the ground proximity warning system, and the traffic collision avoidance system, provide data without reference to any ground installation. The Air Data and Inertial Reference System supplies air data and inertial reference data to various aircraft components for navigation and aircraft control. Control and monitoring of the 3 ADIRUs is through the single ADIRS control display unit located on the overhead panel, or through the Multipurpose Control and Display Units, or MCDUs. The ADIRS CDU has switches and a display window, providing control and monitoring of each ADIRU. The standby instruments used as a backup in the event data from the ADIRS is lost or unreliable are located on the center instrument panel and center windshield post. The radio altimeter height indications are displayed on the primary flight displays, and a synthetic voice announces pre-programmed aircraft heights below 2,500 feet. The weather radar is controlled by the Weather Radar Control Panel located on the left side of the center pedestal. Weather radar images are superimposed on the navigation displays. The data from the VOR, DME, ILS, marker, and ADF systems is displayed on the navigation displays and primary flight displays. Control is normally through the MCDU and flight management computers. If navigation radio tuning capability is lost through the flight management guidance computers, backup tuning is possible through the radio management panels located on the pedestal. The 2 ATC transponders and the traffic collision avoidance system are controlled through the ATC control panel located on the center pedestal. The ECAM memo section will display information regarding the status of the inertial reference system. The message will indicate the number of minutes left to alignment in green before engine start, changing to amber if an engine is started. The Air Data and Inertial Reference System, or ADIRS, is comprised of 3 independent Air Data and Inertial Reference Units. Each Air Data and Inertial Reference Unit is divided into 2 sections, the Air Data Reference Section, or ADR, and the Inertial Reference Section, or IR. The ADIRS supply data to the primary flight displays, navigation displays, flight management and guidance computers, engine control, various flight control computers, ATC transponder, ground proximity warning system, centralized fault system, and cabin pressure control. The Air Data Reference Section receives pneumatic air data from 4 types of sensors. The 3 pitot probes are the captains, the first officers, and the standby probes. The 6 static pressure ports are 2 captain, 2 first officer, and 2 standby ports. The 3 angle of attack, or AOA sensors, are the captains, the first officers, and standby sensors. The 2 total air temperature probes, or TAT probes, are the captains and first officers probes. The various probe locations are on both sides of the forward fuselage. Eight air data modules, or ADMs, convert the pneumatic data from the pitot probes and static ports to digital data. The air data reference section of each air data and inertial reference unit supplies the various aircraft computers with data on the barometric altitude, airspeed, Mach, angle of attack, temperature, and overspeed warnings. The inertial reference, or IR section of each air data and inertial reference unit supplies data on attitude, flight path vector, track, heading, acceleration, angular rates, ground speed, and aircraft position. Normally, with the switching panel attitude heading and air data switches in normal, ADIRU 1 supplies the primary flight display 1, nav display 1, and the DDRMI through the display management computer 1. ADIRU 2 supplies the primary flight display 2 and nav display 2 through the display management computer 2. ADIRU 3 is in standby to replace ADIRU 1 or 2 in the event of a failure of one of the units. The switching panel located on the forward pedestal is used to select attitude heading or air data from ADIRU 3 to the captain or first officer in the event of a partial or total failure of an ADIRU. Selecting the attitude heading selector to captain 3 will supply inertial reference from ADIRU 3 to the number 1 primary flight and navigation displays. Selecting the attitude heading selector to first officer 3 will supply inertial reference from ADIRU 3 to the number 2 primary flight and navigation displays. Selecting the air data selector to captain 3 will supply air data from ADIRU 3 to the number 1 primary flight and navigation displays. Selecting the air data selector to first officer 3 will supply air data from the ADIRU 3 to the number 2 primary flight and navigation displays. The ADRS control and display unit located on the overhead panel has controls and a display panel, which allows control and monitoring of the 3 air data and inertial reference units. An important point to remember regarding the location of the air data and inertial reference unit switches is that the numbering sequence is from left to right, 1, 3, and 2, contrary to the numbering of 1, 2, 3. This follows the logic that the number 1 air data and inertial reference unit provides information to the captain or left side primary flight and navigation displays. The number 2 air data and inertial reference unit supplies the first officer or right primary flight and navigation displays, and ADIRU 3 is in the middle or standby position. It is important to select the proper unit when any switching is necessary, since making a switch selection on an operative unit by mistake may render it inoperative or partially inoperative for the remainder of the flight. The air data reference push-button switches control the output of the air data section of each ADIRU. In the on lights out position, air data output is sent to the system users. Selecting the push-button switch to off will disconnect air data output but will not affect the inertial reference section of the unit. The fault light will illuminate in amber with an ECAM caution to indicate a fault in the associated air data reference section.
The IR mode rotary selectors control the power to each ADIRU and the selection of navigation modes of the inertial reference section. With the IR mode rotary selector in the off position, the ADIRU is not energized. Thus, air data and inertial references are not available. In the normal nav position, inertial data is sent to the aircraft systems. The attitude position will supply only attitude and heading information if the unit is incapable of navigation. Due to IR drift, magnetic heading has to be periodically cross-checked with the standby compass and, if required, updated via the keyboard.
The inertial reference fault light will illuminate in amber with an ECAM caution when a fault is detected in the inertial reference section of the ADIRU. The fault light will illuminate steady if the inertial reference is lost and illuminate flashing if the attitude and heading information can be recovered by selecting attitude on the rotary selector. The inertial reference align light will illuminate steady in white if the inertial reference is in the normal align mode and will extinguish upon completion of alignment. The align light will illuminate flashing if there is an alignment fault or no present position entered within 10 minutes after selecting Navigate on the rotary selector. The align light will also flash if the entered position differs from the shutdown position by more than 1 degree of latitude or longitude. The on-battery light will illuminate in amber if one or more of the ADIRUs is being powered by the aircraft batteries only. If this is the case on the ground, the external warning horn will sound to alert the ground crew. The on-battery light will flash momentarily at the beginning of the alignment phase as the system performs a battery test. The system selector knob controls the ADIRS CDU display. In the off position, the CDU display is not energized, but does not affect the power to the ADIRUs. Selecting 1, 3, or 2 on the data selector knob will allow that system's data to be displayed. Once again, note the numbering sequence of the system selector knob, which matches the ADIRU numbering of 1, 3, 2. The data selector knob selects the ADIRS information to be displayed in the CDU display window. The test position displays the test pattern and illuminates the enter and clear lights on the keyboard. Touch the data selector knob to select track ground speed. In track ground speed, the true track and ground speed are displayed. Touch the data selector knob to display PPAS or present position. PPAS displays the aircraft's present latitude and longitude. Touch the data selector knob to select wind. The wind display is the true wind direction and speed in knots. Touch the data selector knob to display heading. The heading displayed is the present true heading, or if selected on the ground before inertial reference alignment is complete, the time remaining to alignment is displayed. Touch the data selector knob to display status. Status will display the system messages. Normally on the ground before alignment, the message Enter Present Position is displayed. Touch the right arrow to continue. The keyboard is used to enter the present position if it cannot be entered through the MCDU and FMGCs, or to enter the heading in attitude mode. The letter keys N, S, W, and E are for position entry, and the H is for heading entry in attitude mode. The clear key lights will illuminate if an unreasonable value is entered. Pressing the clear key will clear any data in the display which has not yet been entered into the ADIRS. The enter key lights will illuminate when one of the letter keys is pressed. When the keyboard entry is complete, pressing the enter key will enter the data into the ADIRS. The primary flight display displays heading and track, airspeed, attitude, altitude, and vertical speed as computed by the air data and inertial reference systems. For failures of components of the primary flight display, the faulty section will disappear and the associated red flag will appear. These include attitude flag for failure of pitch and roll information, a heading flag for heading information failure, a speed flag for speed information failure, a vertical speed flag for failure of vertical speed information, and an altitude flag for altitude information failure. For discrepancies between the two primary flight displays, an amber warning message is displayed. A check attitude message is displayed for attitude differences greater than 5 degrees. A check heading message is displayed if a heading difference of more than 5 degrees is detected. And a check altitude message is displayed when a difference of 250 feet or more is detected. The navigation display displays ground speed, true airspeed, wind direction in degrees true and speed in knots, a green pointer for magnetic wind direction, a green actual track diamond, and a graduated heading scale as computed by the air data and inertial reference system. The navigation display will replace ground speed, true airspeed, and wind data with dashes if the associated data cannot be computed. As on the primary flight display for a heading failure, the heading graduations disappear and a red heading flag is displayed. A check heading message is displayed for discrepancies greater than 5 degrees between the captain and first officer's displays. The lower ECAM display unit will permanently display, regardless of the page selected, the total air temperature and static air temperature as computed by the air data reference section. If data is not available, the information is replaced by amber X's. The standby instruments are located on the instrument panel and center windshield post. These raw data instruments include the standby compass, horizon, airspeed indicator, altimeter, and digital distance and radiomagnetic indicator, or DDRMI. The standby compass with an attached deviation card is located on the center windshield post. The compass may be illuminated with an internal light controlled from the standby compass switch located on the overhead panel. A lubber line is provided to indicate magnetic heading. The electrically powered standby horizon has roll and pitch scales with a fixed aircraft symbol. The horizon incorporates a flag that will appear if the instrument or electrical power to the instrument should fail. The caging knob, if pulled, will erect and center the horizon. The standby airspeed indicator is driven by direct pitot and static pressure from the standby pitot probe and standby static ports. The instrument has an airspeed pointer and a scale from 60 to 250 knots in 5-knot increments and from 250 to 450 knots in 10-knot increments. The outer rim has bugs to set airspeed references. The standby altimeter is pressured by direct static pressure from the standby static ports. The instrument has a pointer and digital indicator to display altitude in feet. The lower part of the instrument has an altimeter setting knob to adjust the altimeter setting and a digital display for the pressure setting. The outer rim has bugs to mark reference altitudes. The digital distance and radiomagnetic indicator, or DDRMI, has a compass card that is positioned by information from ADIRU 1 and can be switched to ADIRU 3 by the attitude heading switching selector. A single dashed pointer indicates station bearings for VOR 1 or ADF 1, while a double pointer will indicate the bearing to VOR 2 or ADF 2. Selecting either VOR or ADF on a pointer is accomplished with the VOR ADF selectors located on the bottom corners of the instrument. DME distance for DME1 is displayed in the left window, and DME2 is displayed in the right window. The DDRMI has various flags to indicate failures. The DME displays will appear blank if there is a failure of the DME signal, or show dashed white lines for non-computed data for an out-of-range station. A heading flag will appear if heading information fails. The VOR ADF flags indicate a failure of the associated receiver, and the associated bearing pointer will stow at the 3 o'clock position. The aircraft is equipped with 2 VOR receivers, which display VOR information on navigation displays 1 and 2 if VOR is selected on a VOR ADF selector switch located on the Electronic Flight Instrument System or EFIS control panel. The information is also displayed on the DDRMI if VOR is selected on its selector switches. With VOR selected on the EFIS control panel, the navigation display will display a VOR station as a cross, a DME station as a circle, and a VOR DME being represented by a circle and cross combined. The color of the symbol will be blue for a station tuned either manually by the pilot through the MCDU or automatically by the FMGC. The symbol will be green if the nav aid is a current waypoint of the flight plan, and white if it is the two-way point of the flight plan. The VOR 1 bearing pointer is represented by a white single line pointer, and the VOR 2 bearing pointer is represented as a double line pointer. When displayed in the ARC mode, VOR station information is displayed in the bottom corners of the navigation display. The information displays the shape of the associated bearing pointer, the station identification if it is identified by the FMGC, or the frequency if the station is not identified. The mode of tuning is identified by an M for manual tuning, nothing for FMGC automatic tuning, and R for manual tuning through the radio management panel. With the mode selector switch selected to the rose VOR, the VOR course selected manually by the pilot through the MCDU or automatically through the FMGC is displayed in blue. The lateral deviation bar represents lateral deviation with each dot representing 5 degrees. The arrow on the bar represents the to from indication. As with the arc mode, the VOR station information and bearing pointers are also displayed. In ROSE VOR mode, VOR1 station and course information is displayed on Navigation Display 1, and VOR2 station and course information is displayed on Navigation Display 2. The VOR station and course information is displayed in the upper right-hand corner. The information block provides data on VOR station frequency, selected course and station identifier, and mode of tuning, either manually, automatically, or via the radio management panel. Selecting the optional data display push button for VOR DME will display in magenta all VOR and DME stations stored in the FMGC database, except those used in the flight plan or tuned for display, which will remain in blue. If a VOR receiver fails, the associated bearing pointer disappears. Red VOR1 or VOR2 replaces the VOR station information block, and the associated navigation display will display a red VOR1 or VOR2 in the course information block. The course pointer turns red and automatically indicates the 12 o'clock position with no deviation bar. There are 2 DME receivers which will automatically tune the associated VOR or ILS frequency that is presently active. The VOR DME is displayed on the navigation displays 1 and 2 if VOR is selected on the EFIS control panel. The DDR-MI also displays DME information. The ILS DME is displayed on the primary flight display if ILS is selected on the EFIS control panel. If DME information is not received from a station, DME distance information is replaced by dashes. If the DME fails, a red DME flag will replace the DME readout. The aircraft is equipped with 2 ADF systems which are displayed on navigation displays 1 and 2 if ADF is selected on the EFIS control panel. The DDR-MI will display ADF bearing if the associated selector is in the ADF position. With ADF selected on the EFIS control panel, the navigation display will display ADF-1 as a single green course pointer and ADF-2 as a double green course pointer. The NDB station information is displayed in the bottom corners of the navigation display. The information includes the associated bearing pointer shape, the station identification code if the station is identified, or the frequency if the station is not identified, and as with the VORs, if the station was tuned automatically, manually, or through the radio management panel. Selecting the NDB optional data display push button will display in magenta all the NDB stations stored in the database within the selected range if they are included in the flight plan or not. Failure of the ADF system will cause the associated pointer to disappear, and a red ADF flag will replace the station information on the bottom of the navigation display. If there is no signal received from the NDB station, the pointer will disappear and the station frequency is displayed, replacing the identification code. The aircraft is equipped with 2 ILS receivers. The information from ILS-1 is displayed on the primary flight display 1 and nav display 2, while ILS-2 is displayed on Primary Flight Display 2 and Nav Display 1. The Primary Flight Display will display ILS information when the ILS push button is selected on the EFIS control panel. The vertical deviation scale is represented by white dots with the glide slope indicated by a magenta diamond. If the glide slope is out of the displayed range, only half of the diamond will be displayed. The vertical deviation scale will flash if deviation is greater than 1 dot for longer than 2 seconds. The localizer deviation scale is displayed by white dots and magenta localizer diamond. If the localizer is outside of the displayed range, then only half of a diamond is displayed. The deviation scale will flash if the localizer deviation exceeds 1/4 dot for more than 2 seconds. The ILS station information is displayed in the lower left-hand corner of the primary flight display. The information includes the ILS frequency and ILS identification if the ILS signal is identified. The ILS course pointer is displayed as a magenta dagger on the heading scale. If the selected course is outside the displayed heading range, then it is displayed as a numerical value on the side of the heading scale. With ILS selected on the EFIS control panel, the navigation display in ARC or NAV will display the ILS course by a magenta pointer. Selecting the mode selector switch to ROSE ILS, the navigation display will display the ILS station, frequency, course, and station identification if it is identified by the FMGC. The crossover of ILS information on the nav displays is evident with ILS 2 being displayed on nav display 1. The ILS course, selected either automatically or manually through the MCDU, is displayed by a magenta dagger-shaped pointer. The lateral deviation bar displays the localizer deviation. A red glide slope flag and the absence of the glide slope diamond will indicate a failure of the glide slope. A failure of the localizer only will be indicated by a red localizer flag on the localizer scale and the absence of the localizer diamond. A red ILS flag displayed in the lower left corner of the primary flight display will indicate a failure of both the localizer and glide slope signals or no ILS frequency available. The navigation display will display the red glide slope flag for a glide slope failure with a red localizer flag in the center of the navigation display for a localizer failure. The localizer failure will cause the deviation bar to disappear. A failure of the ILS will cause the ILS pointer to turn red and point to the 12 o'clock position. One marker beacon is incorporated into the VOR1 receiver and is displayed on the primary flight displays. The display will indicate the passage of the outer marker by a blue OM, with the middle marker being represented by an amber MM, and the inner marker by a white AWY.
The message ILS will flash in amber when the approach mode is armed and the ILS push button on the EFIS control panel is not selected on.
The radio navigation receivers are normally tuned automatically by the flight management computers via software, or the receivers may be manually tuned by the pilots through the MCDU. If both FMGCs are operating, FMGC1 will tune VOR1, DME1, ILS1, and ADF1. FMGC2 will tune VOR2, DME2, ILS2, and ADF2. The radio navigation receivers that are tuned by the FMGC are displayed on 3 MCDU pages: the radio navigation page, the selected nav aids page, and the progress page. Nav aids that are tuned by the FMGC are displayed in small fonts. The radio navigation receivers may also be tuned manually by the pilot using the radio navigation or progress pages of the MCDU. The required identification code or frequency is entered into the scratch pad, then line selected into the appropriate field using the line select key. The manually tuned nav aid can be overwritten with a new code or frequency, or cleared by selecting Clear on the keyboard, and then the appropriate line select key, which will return tuning to the FMGC. If one FMGC fails, the other FMGC will automatically control both sets of receivers. As displayed, FMGC1 has failed, and FMGC2 has taken control of both sets of receivers. The radio management panels, or RMPs, located on the pedestal can be used for backup tuning if both FMGCs should fail. The radio management panels, normally used to tune communication frequencies, have a standby navigation section at the bottom. Lifting the transparent switch guard and pressing the nav key gives control of navigation radio tuning to the RMPs, eliminating any control by the FMGCs. When activating standby navigation, the nav keys on both RMPs must be pressed. With a failure of both FMGCs, RMP1 can be used to tune VOR1 and ADF1, while RMP2 will tune VOR2 and ADF2, while either RMP will tune both ILSs. The standby navigation keys are used to select the desired receiver. Once the nav key is selected on, pressing one of the radio nav selection keys will display the frequency to which that receiver is tuned. The green monitor light on the selected key will illuminate. The frequency selector knob, which is normally used to select communication frequencies, is also used to pre-select frequencies for the standby navigation systems and to select the desired course for a VOR or ILS. The new frequency is displayed in the standby course window and is then transferred to the active window with the transfer key, thereby tuning the frequency. The desired course is then entered into the standby course window with the frequency selector knob. For a demonstration of setting an ILS frequency and course in standby navigation, touch the nav key to activate the standby navigation section of the RMP. Touch the ILS key to select the ILS receiver. Verify the green monitor light on the ILS key illuminates, and note the last ILS frequency selected is displayed in both frequency display windows. The nav display, if selected to Rose ILS, will display the last tuned ILS and course. Touch the frequency selector knob to tune the new ILS frequency of 111.5, which is displayed in the standby course window.
Next, touch the transfer key to transfer the selected frequency to the active window and tune the ILS. The standby course window now displays the last active course. The nav display now displays the new frequency and the old course. To set the new course of 341, touch the frequency selector knob. The new course is now displayed in the standby course window and is displayed on the nav display. Setting the ILS frequency of 111.5 with the course of 341 using standby navigation tuning is now complete. Note: when using standby navigation tuning, the ILS DME is not displayed on the primary flight displays. If required to set a new ILS frequency, the transfer key must be pressed, which will display the previously selected frequency in both windows, allowing a new frequency to be selected using the frequency selector knob. Touch the transfer key and both windows will display the selected frequency. Touch the right arrow to continue.
When the standby navigation is being used and VHF tuning is required, select the VHF key on the RMP. The nav key must remain in the on position to preserve the standby navigation tuning. With the VHF key pressed and its green light illuminated, normal communication frequency selection may be made through the frequency selector knob. The aircraft is equipped with 2 ATC transponders, which are controlled by one dual control panel. Only the selected transponder operates, which is supplied with altitude information from its associated ADIRU. ADIRU 1 supplies ATC transponder 1 when 1 is selected, and ADIRU 2 supplies transponder 2 when 2 is selected. The ATC control panel is located on the pedestal and has a system select switch which allows selection of transponder 1 or transponder 2. The ATC control panel has a mode select switch, and when selected to standby, will allow both transponders to be supplied by electricity, but they do not operate. With the switch in the on position, the selected transponder operates, and in the auto position, the selected transponder only operates in flight. The altitude reporting switch in the altitude reporting position will transmit aircraft altitude to the interrogating station. In the off position, altitude information is not transmitted, and if TCAS is installed, the ECAM memo section will display TCAS standby in green. The ident switch is pressed when required to transmit the aircraft identification signal. The selector knobs are used to set the assigned ATC code, which is displayed in the display window. The fault light will illuminate if the selected transponder should fail. The aircraft is equipped with 2 radio altimeters. Normally, the information from radio altimeter 1 is displayed on the captain's primary flight display, and radio altimeter 2 information is displayed on the first officer's primary flight display. If one radio altimeter should fail, the remaining radio altimeter's information is displayed on both primary flight displays.
The radio altimeter height information is displayed on the primary flight displays in 3 separate ways. The lower part of the attitude sphere displays the radio height in digital format when the aircraft is below 2,500 feet. The radio height is displayed in green for heights between 400 feet and 2,500 feet, changing to amber below 400 feet when there has been no decision height entered into the MCDU. With a decision height entered into the MCDU, the radio height indication will be displayed in green between decision height plus 100 feet and 2,500 feet, changing to amber below decision height plus 100 feet. When the aircraft reaches the decision height as entered into the MCDU, the letters DH will be displayed in amber above the radio altitude information, flashing for 3 seconds, then remaining steady.
The primary flight display also has a red ribbon on the altitude scale, which represents the field elevation and is active below 570 feet. As the aircraft descends below 570 feet, the red ribbon moves up. The distance between the top of the ribbon and the altitude window represents the radio height. When the aircraft is on the ground, the top of the red ribbon will be in the center of the altitude window. The third indication is the lower line of the attitude sphere, which moves up below 300 feet. The distance between the lower line and the horizon line is another radio height indication. On the ground, the lower line will be merged with the horizon line.
If one radio altimeter should fail, the remaining radio altimeter information will be displayed on both primary flight displays. If both radio altimeters fail, an ECAM caution will be triggered and a red RA will replace the radio height on both primary flight displays. With the failure of both radio altimeters, the aircraft will go from normal law directly into direct law when the landing gear is extended. Also, the approach will be limited to a Category 1 ILS, and the ILS approach cannot be armed using the approach push button on the FCU.
Along with the radio altitude indications, a synthetic voice generated by the flight warning computer will call out heights below 2,500 feet. The synthetic voice, which is audible with the cockpit loudspeakers on or off, is programmable by the operator and normally calls out heights of 400, 50, 30, 20, 10, and 5 feet. If a decision height was entered in the MCDU, the synthetic voice will announce 100 above and minimum. Retard is announced at 20 feet without an autopilot engaged, or 10 feet with an autopilot and autothrust engaged.
400, 100 above, minimum, 50, 30, 20, retard, 5.
The aircraft is equipped with one weather radar system, which has a radar antenna in the nose cone and a control panel on the left side of the pedestal. The radar control panel has several switches to control the radar. The system on-off switch is used to energize the radar by selecting on. Off will de-energize the system. The gain knob is used to adjust the sensitivity of the receiver. Calibrated is the normal setting, which will automatically set the calibration.
The mode select switch is used to select the modes of operation. The weather position will indicate the intensity of precipitation by different colors, with black the lowest intensity, and green, amber, and red to indicate higher levels of intensity. The weather and turbulence position will display turbulence areas within precipitation in magenta, within the 40-mile scale. The turbulence position will only display turbulence with no precipitation returns. The map mode will display ground return in various colors, with black used for calm water, green for ground, and amber for cities and mountains. The tilt knob is used to control the antenna tilt, with 0 representing the horizon as referenced by Air Data and Inertial Reference Unit 1. The ground clutter suppress switch is used to suppress ground return on the display and is spring-loaded to off.
The weather radar pictures displayed on the navigation display in all modes except plan, and image brightness is controlled by the outer knob of the navigation display off brightness knob. The weather radar image is color-coded for different levels of precipitation intensity. Black or no image is used for the lowest intensity, and with green, amber, and red used for increasing levels of intensity. The antenna tilt between the horizon and the beam axis is displayed in degrees in the lower right corner of the navigation display. If the calibration mode is not in calibrate, then manual is displayed by the tilt display. With a failure of the weather radar system, the failure message will be displayed in the lower right corner of the navigation display. Failures, which cause a loss of the weather radar display, will be displayed in red, and failures that affect the image quality will be displayed in amber. The Ground Proximity Warning System, or GPWS, will issue oral and visual warnings if the aircraft is likely to enter a hazardous situation in the vicinity of terrain. The GPWS control panel is located on the overhead panel and the two GPWS lights are located on the instrument panel. The synthetic warning voice is audible through the cockpit loudspeakers if the loudspeakers are selected on or off. The GPWS protection area is normally between 30 feet and 2,450 feet on the radio altimeter, with some newer aircraft modified with protections down to 10 feet. The GPWS has 5 warning modes, which are Mode 1, excessive rate of descent, Mode 2, excessive terrain closure rate, Mode 3, altitude loss after takeoff or go-around, Mode 4, unsafe terrain clearance when not in landing configuration, and Mode 5, descent below glide slope. The visual warning for Modes 1 to 4 is the illumination of the red GPWS light, with Mode 5 illuminating the amber glide slope warning on the lower half of the GPWS light. The GPWS is controlled by one ground proximity warning computer, which receives data from several aircraft computers. The radio altimeter supplies radio height, while ADIRU number 1 supplies aircraft position, heading, altitude, vertical speed, and airspeed. ILS-1 provides data on glide slope and localizer deviation along with the runway heading. FMGC-1 provides aircraft position and track, so the GPWS can be programmed for airports with non-standard approaches to eliminate nuisance warnings. The Landing Gear Control Interface Unit 1 supplies data on landing gear position, and the Slat Flap Control Computer 1 provides data on the flap landing configuration, either Config 3 or full. The Flight Warning Computer will inhibit all GPWS modes if a stall warning is present. The Ground Proximity Warning Computer provides data for the oral and visual warnings, as well as fault indications for the ECAM and the system fault light. The GPWS is controlled through the overhead GPWS control panel. Selecting the system push-button switch to off will inhibit all GPWS warnings, and the push-button switch will indicate fault, along with an ECAM caution if the GPWS is faulty. Selecting the glide slope mode push-button switch off will inhibit the glide slope mode 5 warning if intentional descent below the glide slope is required, for example, for a non-precision approach. With the flap mode push-button switch selected off, the Mode 4 Too Low Flaps warning is inhibited to avoid nuisance warnings when landing with abnormal flap settings due to flight control faults. Selecting the Landing Flap 3 push-button switch to on will inhibit the Mode 4 Too Low Flaps warning. This is used to avoid nuisance warnings when intentionally landing in Config 3. The GPWS glide slope push button will illuminate GPWS in red for Modes 1 to 4. The push button will illuminate amber glide slope for the Mode 5 glide slope warning. With the amber glide slope illuminated, pressing the push button will cancel the light and oral glide slope warning. Pressing the GPWS glide slope push button on the ground or in flight between 1,000 feet and 8,000 feet radio altimeter will test the GPWS warning light and audio warnings. During a GPWS warning, the audio alert may be canceled by pressing the emergency cancel push button on the ECAM control panel. A GPWS alert does not call up any ECAM actions. However, GPWS recovery actions, which should be committed to memory, are covered in FCOM 3 Abnormal and Emergency Procedures. If the GPWS alert occurs during night or IMC conditions, initiate the recovery procedure immediately. If the alert occurs during daylight, visual weather conditions, and terrain and obstacles are clearly in sight, the warning may be considered cautionary. Take any necessary corrective actions to ensure a safe flight path. As can be seen on the accompanying checklist, the actions for the alerts, whoop whoop pull up and terrain terrain, whoop whoop pull up, are to simultaneously select the autopilot off, increase pitch applying full back side stick if required, advance the thrust levers to toga, check that the speed brakes are retracted, and level the wings. When clear of obstacles and the GPWS warning has ceased, decrease the pitch attitude and accelerate the aircraft. When the speed is above VLS and vertical speed is positive, clean up the aircraft as required. The alert, terrain, too low terrain, requires the pilot to adjust the flight path or initiate a go-around. The alert sink rate, or don't sink, requires the pilot to adjust the pitch attitude and thrust to silence the alert. The too low gear or too low flaps warnings can be canceled by selecting the correct configuration or by performing a go-around. With the glide slope alert, the aircraft must be established back on the glide slope or switch off the glide slope mode push-button switch if flight below the glide slope is intentional, as for a non-precision approach. The GPWS Mode 1 excessive rate of descent is divided into two boundaries. With high descent rates toward terrain, penetrating the first boundary will generate the repetitive oral alert sink rate, and the GPWS light will illuminate in red. The checklist action is to adjust pitch and thrust to silence the alert, which will end when the aircraft leaves the warning area.
Sink rate, sink rate, sink rate.
If, after entering the sink rate boundary, the excessive rate of descent is not corrected or increases and enters the pull-up boundary, a repetitive whoop-whoop pull-up is generated.
Pull up, pull up, pull up.
The checklist actions in this case are to simultaneously select the autopilot off, increase pitch, applying full back side stick if required, advance the thrust levers to toga, check that the speed brakes are retracted, and level the wings. Once the aircraft is on a safe flight path and the GPWS alert has ceased, decrease pitch and accelerate, cleaning up the aircraft at the appropriate speeds. The GPWS Mode 2 warning excessive terrain closure rate is generated when the aircraft closure rate and radio altitude are within the boundary. The upper limit of the boundary is 1,650 feet radio altitude if the speed is 220 knots or less, increasing to 2,450 feet radio altitude if the speed is 310 knots or less. If the flaps are in the landing configuration, the upper boundary is approximately 800 feet. As the aircraft enters the boundary, the GPWS light will illuminate, accompanied by an oral alert of terrain repeated twice, changing to a repetitive whoop-whoop pull-up, which will continue until the aircraft leaves the warning envelope.
Terrain, terrain. Pull up, pull up, pull up.
Once again, the checklist actions in this case are to simultaneously select the autopilot off, increase pitch, applying full back side stick if required, advance the thrust levers to toga, check that the speed brakes are retracted, and level the wings. When the aircraft leaves the boundary, the GPWS light will remain illuminated, and the oral alert terrain will continue until the aircraft gains 300 feet. If the aircraft should enter another warning area during the 300-foot gain, then the warning sequence is reset and starts again with a new reference altitude. Once the aircraft is on a safe flight path and the GPWS alert has ceased, decrease pitch and accelerate, cleaning up the aircraft at the appropriate speeds. The GPWS Mode 3 warning, altitude loss after takeoff, is generated if the aircraft should descend during the climb, immediately after takeoff or a go-around. When the aircraft enters the boundary, the GPWS light will illuminate, along with the oral alert of don't sink, which is repeated until the aircraft leaves the warning area.
don't sink, don't sink, don't sink.
The checklist in this case requires that the pitch and thrust be adjusted to silence the alert. Once the aircraft is established in level flight or a climb, the visual and aural warnings will stop. The GPWS Mode 4 warning, unsafe terrain clearance, is divided into 3 different alerts, depending on airspeed, radio altitude, and aircraft configuration. With the landing gear up and the flaps not in the landing configuration, the warning area is divided into 2 segments. If the aircraft speed is greater than 190 knots and radio altitude below 1,000 feet, then the terrain, too low terrain alert is triggered. If the aircraft is below 500 feet and less than 190 knots, the too low gear alert is triggered. In this example, the aircraft is too low with the landing gear not extended and airspeed above 190 knots. The red GPWS light illuminates, and the aural alert, terrain, too low terrain, is continuously repeated.
Terrain, too low terrain, too low terrain, too low terrain.
The corrective action for terrain, too low terrain is to adjust the flight path or initiate a go-around. Once clear of the warning area, the warnings will stop. Another configuration for the GPWS Mode 4 warning, unsafe terrain clearance, is Mode 4B, which is activated if the landing gear is down or if the flaps are in landing configuration, if the aircraft is below 245 feet radio altitude and the speed is below 159 knots with the landing gear down but the flaps are not in the landing configuration, the alert too low flaps will be repeated continuously and the red GPWS light illuminates.
Too low flaps, too low flaps, too low flaps.
The checklist action is to lower the flaps to landing configuration or to perform a go-around. Once the flaps are in the correct position or the aircraft leaves the warning area, the warning will stop. The other scenario for the GPWS Mode 4B warning is if the flaps are in landing configuration and the landing gear is not down, with the aircraft radio altitude below 245 feet and airspeed below 159 knots. The warning generated in this envelope is a repetitive, too low gear with the red GPWS light.
Too low gear, too low gear, too low gear.
The checklist action for too low gear is to lower the landing gear or perform a go-around. Again, once the configuration is corrected or the aircraft is out of the warning area, the warning will stop. The last warning, GPWS Mode 5, descent below glide slope, is activated if the aircraft is below 1,000 feet radio altitude and descends below the glide slope by more than approximately 1 1/4 dots. When the aircraft is in the glide slope warning area, the aural alert glide slope is repeated and the amber glide slope light illuminates. The checklist action is to establish the aircraft back on the glide slope.
Glide slope, glide slope, glide slope.
If the aircraft trajectory is not corrected back to the glide slope and the aircraft descends below the glide slope by more than 2 dots and below 300 feet radio altitude, entering the hard warning area, the audio glide slope alert will increase in volume.
glide slope, glide slope, glide slope.
Again, the corrective action is to establish the aircraft back on the glide slope. The glide slope warning may be canceled by selecting the glide slope push-button switch to off. This would be done in the event of intentional descent below the glide slope as for a non-precision approach. The Traffic Collision Avoidance System, or TCAS, will detect and display transponder-equipped aircraft which are within the immediate area that may be a potential collision threat. If required, TCAS will provide the crew with visual and audible indications to avoid the intruder by either climbing or descending. The TCAS detection area is limited to intruders flying within a 14 nautical mile range and from altitudes of 9,900 feet above and below the aircraft. The components of the Traffic Collision Avoidance System are two TCAS antennas, which are positioned on the top and the bottom of the fuselage, a single-channel TCAS computer, and two Mode S ATC transponders. The TCAS is controlled from the ATC TCAS panel located on the pedestal. The TCAS computer receives information from various aircraft components, which include two antennas, the radio altimeter, which supplies radio height, and the landing gear control interface unit, which supplies ground flight information. ADIRU 1 will supply attitude and heading information, and depending on which ATC transponder is operating, either transponder 1 or 2 will supply coded transponder information. The TCAS computer displays indications on the captain and first officer's primary flight and navigation displays, with corresponding oral messages issued from the speakers. The TCAS oral alerts will be inhibited if warnings from the ground proximity warning system or stall warning are active. The TCAS will interrogate the transponder of any intruder, and with the transponder reply, determine the intruding aircraft's relative bearing, range, closure rate, and if the intruder is configured with a Mode C or S transponder, its relative altitude. The TCAS will compute the intruder's trajectory, the closest point of approach or CPA, and estimated time to the closest point of approach or TAU. If a collision is detected, the TCAS will trigger oral and visual advisories and coordinate vertical orders with the two TCAS-equipped aircraft. If the intruding aircraft does not have TCAS, there will be no TCAS coordination, and only the TCAS-equipped aircraft will generate the vertical orders. The TCAS has 4 levels of intruder classifications: proximate, traffic advisory or TA, resolution advisory or RA, and if installed, other intruders. The proximate classification is generated when an intruder is not a collision threat, but is within 6 nautical miles of the aircraft, and the difference in altitude is plus or minus 1,200 feet. The navigation display will display the proximate traffic as a solid white diamond. Proximate traffic is only displayed if another traffic or resolution advisory is present. The traffic advisory is generated when there is a potential threat of a collision when the time to the closest point of approach is approximately 40 seconds. The navigation display will display the intruder as an amber circle accompanied by an oral message of traffic, traffic. The resolution advisory is generated when there is potential threat of a collision when the time to the closest point of approach is approximately 25 seconds. The navigation display will display the intruder as a red square accompanied by an oral vertical message. The vertical speed scale of the primary flight display will display areas of red or green indicating safe or forbidden areas of vertical speed. If installed within TCAS programming, other intruders within plus or minus 2,700 feet, which are not a collision threat and are not proximate, TA or RA, are displayed on the navigation display as an empty white diamond. The TCAS is controlled by the TARA switch on the ATC TCAS control panel. The TARA selection will display all intruders. The TA position is selected by the crew for degraded aircraft performance, such as with an engine inoperative or when operating on closely spaced parallel runways. The TA mode converts all RAs to TAs, thus there are no vertical advisories on the PFD. The TA mode is also automatically selected during stall or GPWS conditions. When operating in traffic advisory mode, the message TA only is displayed on the navigation displays. The TCAS will only display the 8 most threatening intruders on the navigation displays. The traffic will be displayed in the ARC and all ROSE modes only within the 10, 20, and 40 nautical mile range selections. In the 10 and 20 mile range selection, a 2.5 mile range ring is displayed in white. The TCAS displays traffic symbols on the navigation display. Proximate traffic is displayed as a white solid diamond, a traffic advisory as an amber circle, a resolution advisory as red square, and if installed, other intruders as empty white diamonds. If the intruder is equipped with a mode C or S transponder, the intruder's relative altitude is displayed above or below the symbol in hundreds of feet. If the intruder's vertical speed is greater than 500 feet per minute, a vertical speed arrow will be displayed beside the symbol. The direction of the arrow corresponds with the intruder's vertical speed. If the intruder is off the selected scale, half of the symbol will be displayed. If the bearing for a TA or RA intruder is not available, then the intruder's range and relative altitude will be displayed in digital form at the bottom of the navigation display. The no bearing digital indication will be displayed either in amber for a TA or in red for an RA. The navigation display will display range and mode messages to alert the crew. The message "Reduce range" is displayed when a TA or RA is detected and the navigation display range is above the 40 nautical mile selection. The message "Change mode" is displayed during a TA or RA when the navigation display is in the plan mode. Either message will be displayed in amber for a TA intruder and red for an RA intruder. The message will flash for 9 seconds from initial display and then remain steady. The navigation display will display the message TCAS in red associated with an ECAM warning if the TCAS experiences a failure. The message TA only is displayed when the TA-RA switch is selected to TA. The primary flight displays will display RA vertical orders on the vertical speed scale. The normally gray vertical speed background. The navigation display will display range and mode messages to alert the crew. The message "Reduce range" is displayed when a TA or RA is detected and the navigation display range is above the 40 nautical mile selection. The message "Change mode" is displayed during a TA or RA when the navigation display is in the plan mode. Either message will be displayed in amber for a TA intruder and red for an RA intruder. The message will flash for 9 seconds from initial display and then remain steady. The navigation display will display the message TCAS in red associated with an ECAM warning if the TCAS experiences a failure. The message TA only is displayed when the TA-RA switch is selected to TA. The primary flight displays will display RA vertical orders on the vertical speed scale. The normally gray vertical speed background will change to areas of red, indicating a vertical speed range where the risk of conflict is high, and areas of green to indicate recommended vertical speed ranges. the aircraft can also be flown in the gray vertical speed range without risk of conflict. The message TCAS is also displayed in red for a TCAS failure. The oral messages generated by the TCAS for traffic advisory and resolution advisory intruders are
traffic, traffic,
for TA intruders,
climb, climb, climb,
which advises the crew to initiate a climb corresponding to the green vertical speed area.
climb, crossing, climb, climb, crossing, climb,
Advises the crew to climb corresponding to the green vertical speed area and that the aircraft will climb through the intruder's altitude.
increase, climb, increase, climb,
Is issued after a climb message if the vertical speed is not sufficient to achieve safe vertical separation with the intruder.
reduce, climb, reduce, climb,
Advises the crew to reduce the climb to that corresponding to the green vertical speed area.
descend, descend, descend,
Advises the crew to descend corresponding to the green vertical speed area.
descend, crossing, descend, descend, crossing, descend,
Advises the crew to descend corresponding to the green vertical speed area and that the aircraft will descend through the intruder's altitude.
increase, descent, increase, descent,
Is issued after a descend message if the vertical speed is not sufficient.
reduce, descent, reduce, descent,
Advises the crew to reduce vertical speed to the green vertical speed area.
climb, climb now, climb, climb now,
Is issued after a descend message if the intruder's trajectory has changed.
descend, descend now, descend, descend now,
Is issued after a climb message if the intruder's trajectory has changed.
monitor vertical speed, monitor vertical speed,
Advises the crew to maintain the present vertical speed, which will ensure that the vertical speed remains outside the red areas.
clear of conflict,
Indicates that the range is increasing with safe separation and that it is safe to return to the assigned clearance. The ECAM memo area will display the message TCAS standby in green if the ATC transponder or TCAS is selected to standby. TCAS standby is also displayed if ATC altitude reporting is selected off or if both ATC transponders or both radio altimeters have failed. The resolution advisory will generate 3 different advisories depending on intruder situations. These advisories are preventive, corrective, and modified corrective. During the preventive advisory, the actual vertical speed may be maintained with a PFD vertical speed area displaying a red area to be avoided. The corrective advisory is triggered when the actual vertical speed is within the range to avoid with a PFD vertical speed area displaying green recommended areas. The modified corrective advisory is used when an RA is already displayed and a correction to vertical speed is required due to the intruder changing vertical speed. During TCAS warnings, there are no ECAM warnings triggered. Related TCAS procedures are covered in FCOM 3, the Abnormal and Emergency section. As displayed in the TCAS warnings procedure, the traffic advisory does not call for any maneuvering, only an attempt to make visual contact with the intruder. The preventive resolution advisory, monitor vertical speed, requires the pilot to maintain or adjust the vertical speed as required to avoid the red area of the vertical speed display. Attempt visual contact with the intruder and notify ATC. When the message "Clear of conflict" is issued, return to normal navigation as per ATC clearances. The corrective resolution advisory, all climb and descend messages, requires the pilot to respond smoothly within 5 seconds to the RA. If engaged, the autopilot is selected off and the auto thrust is disconnected. The pilot then adjusts thrust and vertical speed as required to avoid the red areas of the vertical speed scale. During the RA, attempt visual contact with the intruder and notify ATC. When the message, "Clear of conflict," is issued, return to ATC clearances and re-engage the autopilot and auto thrust if desired. The following screens contain various TCAS warning scenarios. In this situation, an intruder is at the 12 o'clock position at 7 nautical miles and 500 feet above your altitude. The navigation display will display a traffic advisory accompanied by an oral warning of
Traffic. Traffic.
do not maneuver the aircraft based on the TA only, but attempt to make visual contact with the intruder. Be prepared to maneuver if the TA changes to RA. The intruder has now moved closer and the TA has changed to a resolution advisory. The navigation display now displays the RA at 5 nautical miles and 500 feet above the aircraft's altitude, accompanied by the preventive oral warning,
Monitor vertical speed. Monitor vertical speed.
The vertical speed area of the primary flight display displays a red area in the upper half. This indication requires that the crew not climb, but to remain in level flight or descend. This scenario shows an intruder at 12 o'clock and 100 feet below the aircraft's altitude. The corrective oral warning to this RA is
Climb. Climb. Climb.
and the vertical speed area of the primary flight display displays a green safe area in the upper section. The crew actions are to promptly and smoothly, within 5 seconds, establish the aircraft in a climb of 1,500 feet per minute. In this scenario, the intruder at 12:30 is 400 feet above and descending at a vertical speed greater than 500 feet per minute. The corrective RA oral warning in this case is
Climb. Crossing. Climb. Climb. Crossing. Climb.
From the last scenario, after the RA climb has been initiated, the intruder has stopped its descent at 100 feet above the aircraft. The RA changes to an additional corrective RA with an oral warning of
Increase climb. Increase climb.
and the vertical speed area indicating the green area at a higher rate of climb. The crew actions are to immediately and smoothly within 2.5 seconds increase the rate of climb to 2,500 feet per minute. In the previous scenario, if the intruder changed its descent to a climb while the aircraft was responding to the climb RA, the RA would change to an additional corrective RA. The oral warning would change to
Descend. Descend now. Descend. Descend now.
and the vertical speed area would display the current rate of climb as red with a safe green area at 2,500 feet per minute down. The crew actions are to initiate a descent from the climb within 2.5 seconds to avoid the climbing intruder. After a resolution advisory intruder is no longer a threat, the message
Clear of conflict.
is issued and the crew must promptly return to the last ATC clearance. During the preliminary cockpit check, the captain will set up the ADIRS for alignment. The IR mode rotary selectors are selected to nav in the sequence 1, 2, 3, or left, right, center. Touch the IR mode rotary selectors 1, 2, and 3 to select nav. Once the ADIRS are selected to navigate, the MCDU will automatically display the aircraft status page. On the status page, confirm that the correct date for the active database is in effect and the performance factor is correct for the flight plan. To correct the performance factor, type the performance factor into the MCDU scratch pad, then select Line Select Key 6 right. To align the ADIRS, select the Initialization A page on the MCDU by pressing the init function key. With the init page selected, the company route is entered into the MCDU scratch pad using the MCDU keyboard. In this example, the company route 1 for Vancouver to Calgary is being entered into the scratch pad. Selecting Line Select Key 1 left now enters the company route into the company route data field. Once the company route has been entered, the originating airport, latitude and longitude are displayed at line 4 along with an amber line IRS at line 3 right. Line selecting Key 3 right will continue alignment of the ADIRS. After ADIRS alignment, confirm the database originating airport coordinates with the actual airport chart coordinates. During the cockpit geographic check of the ground proximity warning system panel, confirm that the 4 push-button switches, System, Glide Slope Mode, Flap Mode, and Landing Flap 3 are in the normal in, lights out position. During the cockpit geographic check of the EFIS control panel, set the correct barometric reference in the barometric reference display window using the barometric reference selector. Select the Flight Director push button on and confirm the ILS push button is off, its light extinguished. Check that the 5 optional data display push buttons are off and lights out. The Mode Select switch is selected to ARC or ROSE nav, with the Range Select switch positioned to the 10 or 20 nautical mile scale. The 2 ADF VOR select switches are selected to ADF or VOR as required for the departure.
During the check of the standby instruments, check that the indicated airspeed is 0 and set the airspeed bug to the planned V2 speed. On the standby altimeter, set the correct barometric pressure. Check that the altitude is correct and set the acceleration altitude on the outer bug. Check that the standby horizon is erect and there is no flag visible. Check the DDRMI heading against the navigation display and standby compass, and set the ADF VOR selector switches as required for the departure.
During the cockpit geographic check of the weather radar, check that the radar is selected off as there is no standby or ground test feature. Check that the gain knob is in the calibrated position, the mode selector is in weather or weather and turbulence, and set the tilt to 5 degrees up.
As the cockpit geographic check progresses, check that the switching selector switches, attitude heading and air data are in the normal position. The EIS, DMC, and ECAM ND transfer selector switches must also be in the normal position and are covered in the indicating and recording module.
On the radio management panel, ensure that the on-off switch is on and the green nav light is extinguished, that is, that the standby nav feature is not activated. During the cockpit geographic check of the ATC panel, set the system selector switch to 1 for odd number flights and 2 for even number flights. Check that the mode select switch is in auto, the altitude reporting switch is on, and the TCAS mode selector is in TARA. When a fault is detected in the air data section of an air data and inertial reference unit, the associated air data reference fault will be triggered. A single chime will sound, the master caution will illuminate, the fault light on the affected ADR push-button switch will illuminate, and the ECAM memo area will display the fault with the required ECAM actions. There is no specific system page called up on the lower ECAM display unit. For the ADR1 fault, the first ECAM action is to select the Air Data Switching Selector to Captain 3, which will switch Air Data Reference 3 to the Captain's instruments. Touch the Air Data Selector to select Captain on 3. The next ECAM action is to select the Ground Proximity Warning System off, as ADR1 only supplies data to the GPWS. Touch the GPWS system push-button switch to select the GPWS off. The final ECAM action is to select the faulty ADR off. Touch the ADR1 push-button switch to turn it off. The inertial reference fault will be displayed for a fault in the inertial reference section of the Air Data and Inertial Reference Unit. The ECAM action for the IR2 fault is to switch the attitude heading selector to First Officer on 3, which will switch the inertial reference of ADIRU 3 to the First Officer's instruments. If the difference in heading between the captain and first officer's displays is greater than 5 degrees, the navigation heading discrepancy fault will alert the crew. The first ECAM action is to cross-check the headings. The heading check can be performed by selecting heading on the ADIRS control panel, then selecting 1, 2, and 3, thus displaying the headings for comparison, or by cross-checking the captain and first officer's headings with a standby compass. When the faulty heading is confirmed, the crew can then select the attitude heading switching selector to captain or first officer on 3 as required, which will switch IR3 inertial reference data to the captain or first officer's instruments. In this case, the first officer's heading is incorrect. Touch the attitude heading selector to switch the first officer on 3. If the captain's and first officer's attitude on the primary flight displays differ by 5 degrees or more, the attitude discrepancy fault is triggered. The first ECAM action is to cross-check the attitude on the primary flight displays 1 and 2 with the standby horizon. When the faulty attitude indication is confirmed, select the attitude heading switching selector to captain or first officer on 3 as required. In this case, the first officer's attitude is faulty. Touch the attitude heading selector to transfer the first officer to ADIRU number 3. A fault detected in the ground proximity warning system will trigger the GPWS fault. The ECAM action is to turn the GPWS system push-button switch off. Touch the GPWS push-button switch to turn it off.